This is office hours on Tuesday, March 31st. I'm going to answer some of the questions that came up. Next time around, I might try to host a Google Hangout so we can do some of this live. Even if you didn't have a question, hopefully some of the questions that came up you'll find useful. These came in through the email, through Google Classroom, as well as through the Desmos activity. So I'm going to just scroll through and try to answer most of these. And then if you still have questions, I'll do another office hours on Thursday. So if you're just now getting into starting the lesson and you have a question, please post it. So here were some of the questions that came up. When solving addition and subtraction problems, does it matter what number you choose that is common in all scenarios? So I'm assuming this question was about sort of these questions. And so when you're doing an addition problem, it is best to factor out the greatest common factor, which is 4 and 16 is 4. And for this problem, the greatest common factor was 100 because 100 goes into 200 and into 100. And so that is sort of the answer to that question. What number do you choose? I would choose the greatest common factor so that you're certain that your answer is fully simplified. Um, Another question that came in is, can you have multiple correct answers? So for example, on slide 23, most people got 18, like for number 20 or slide 23. Let's see, slide 23. Cool. So let's take a look at slide 23. And I will actually try to do this one. So 3 square root 72 n to the eighth. So let's first just answer this, which is that there is only one correct answer. So this answer, 9 n to the fourth square root of 8, is not fully simplified because 8, actually as small as it is, does simplify further. And if this were to be simplified more, would turn into this answer. So essentially, if you're kind of going through this and scoring this, this means that this is partially correct. And you want the fully simplified answer. There is only one correct answer for these. And so I'm guessing what this person did, and it's pretty common, is you do 8 times 9. You found a perfect square. So we already had a 3. This 3 was this 3. Then we have the 3 that comes from the 9. And then we have an 8. And 8 is so small, but what we need to start to realize is that actually 8 is 4 times 2. And so there is a perfect square that's going to come out, and this one will stay inside. We'll start to build this. And now we need to deal with n to the 8th. And so n to the 8th, I can think of as n to the 4th times n to the 4th. And so there is a pair, and out comes one representative. And what we might be realizing is if it's even, we're basically just cutting it in half. And if it's odd, we're just going to reduce it by 1 and then apply that rule. And so notice I'm picking n to the 4th and n to the 4th and not n to the 2nd and n to the 6th because I can now just be done with this problem and extract it. So I'm choosing two identical terms for my factor tree or factors for my factor tree because then once I have those pairs here, I have, in a sense, a perfect square. All right, and we have then 2 times 9, which is 18, n to the 4th root 2. So moral of the story is that square root of 8, let's look at a second example. Square root of 8, we need to start to kind of train ourselves that if we see a root 8 in our answer, that root 8 is 2 root 2. And that means that if there is an 8 as our radicand, we do need to simplify further. And root 8 shows up a lot. In fact, you might factor tree this a couple times and just start to just naturally know this one or memorize that the square root of 8 is 2 root 2, or 2 times the square root of 2. So I'm going to go back and see if I'm answering all of these questions correct. So we got this answer. I think we answered that. Um, there's a question about, are we still going to take the Module 5 test? I wish I knew an answer to this. Once I get an idea about what the long-term plan is for the rest of the school year, and what sort of the grading policies are going to be, then I can maybe start to answer some of these questions. But for now, if you can just hold off on that and don't be too stressed out about this, just try to focus on the things I'm posting. And another question, is there any way to check your answer? Unfortunately, there really isn't a way to check your answer because these are expressions. But one of the things that we could look at with this one, um, let's make a third example. And let's make it be just the square root of 72, just to make this a little bit easier. And so what we saw from that was that the square root of 72 had a 3 in it, it had a 2 in it, a 3 and a 2, and that 3 was that 3. And it had a 2 left over. So um, looking at an easy example, there is not a way to check these, but there is, if you were to kind of analyze this for a second, a way to check that you sort of did this correct. And then you'd have to also think about the variable part of this. But for the number part, if a 6 came out, that means that in a previous life, this was a 36, because that would mean that if we were to put the 6 back inside the radical, it would be this, that this is equal to what we started with, which actually then proves that, or kind of verifies that I am correct, because 36 times 2 is 72. So when I go to simplify things and I get my final rational part of my answer, the answer that's out front, and I think about squaring it to put it back inside, and I multiply it times this number, that will tell me that I did this correct. So for example, let's check. Let's come up with a fourth example. Let's try root 8. So we said that root 8 was 2 root 2, which means that if I were to kind of undo the simplifying, this 2 is that 2. In this 2, to put it back under the radical, I need to undo the square root, or square it. Oh, yeah. So that actually does get me back to where I started. So there are maybe some ways to just see that you're on the right track. But unfortunately, since these are not equations, there's no way to just plug things back in and be guaranteed that it is correct. But hopefully that offers some options. This question was basically, are there any other methods or tips or tricks? Just out of curiosity, there really isn't. This is the shortest way to do this. We will also look at how to do a cube root, which means we'll be looking for sets of 3. But as we do more of these, we might realize better or quicker ways to break apart or factor tree things. And we've also started to maybe figure out the shortcut for even exponents, which is just cut it in half. And that brings us to some of the other questions that came up. So I'll kind of come back to that, although I think I answered that. If there's a negative symbol, do we multiply by -1? Or is there a property for that? That's a great question as well. And so we'll look at maybe a fifth example, which is that, yeah, if we have a negative, then we just carry it over. We can think of this as -1 times that. We don't include it in our factor tree, and we would just bring this over and say that this is -2 root 2, or -1 times 2 root 2, which is -2 root 2. So essentially what you can do if you have a negative out front is just do it as if it wasn't there, but don't forget to include it in your final answer. And I guess, like, what property is this? This just goes back to kind of what a negative sign means. back in 7th grade. And kind of also like we did in module 5, this just means take the opposite of the square root of 8. So do square root of 8 and apply a negative out front. That's a good question. Let's keep kind of looking at what else we've got here. My day is going great. I hope everyone else is doing good. Hopefully we'll be able to um, do some other type of hangout, like a Google Hangout, and see one another. This one says, I'm a little confused on how to find the square root of an exponent, like x to the 7th. So let's take a look at that. So x to the 7th. And then let's also maybe try maybe square root of x to the 9th. Let's do another one that might be the square root of x to the 20th. And let's do another one that is square root of x to the 101st. Excuse me. Okay. So first off, what we could do is just multiply this out, right? Think about this as 2, 4, 6, 7. We got 1 pair, 2 pair, 3 pairs, and 1 left over. Oh, so 3, if I actually think about cutting 7 in half, half of 7 is 3.5. So I can start to see maybe some shortcuts to not have to do this option. So then one way that I suggested was that with x to the 9th, since it isn't even, I'm going to make it x to the 8th times x to the 1st. Whenever it's odd, I'm always going to go with x to the 1st. Then I'm going to cut this in half, and this will stay inside. That's my simplified answer. And in fact, if I think about this, half of 9 is 4.5. So I can also see maybe some other tips and tricks to go through this. So let's go back to this one and kind of redo this one again. So without expanding it out, I would do x to the 6th times x to the 1st. I'm always going to stick with x to the 1st. And by the way, frankly, you can, at some point, if not now, do this without even doing this step. But if you are going to do this step, I would suggest doing it this way. So x to the 6th is a pair of x cubes, because x cubed times x cubed is x to the 6th. We add the exponent, and that one is stuck inside. So x to the 20th is x to the 10th. And x to the 101st would be x to the 100th times x to the 1st, which would be x to the 50th root x. So picking a couple to kind of analyze and practice that you could check by expanding out, or that you could check with the homework key or the lesson key, I think allows you to be more comfortable with if the variable is the part that's kind of tripping you up. And another question that came in through Google Classroom, I don't think it was necessarily posted here, was about this slide, square root of 128. So square root of 128, let's look at this one. And the question was also similar to questions that I mentioned previously. Let me go over actually to this other lesson. All right. And I think it was about this, was these are equal, and are these both good answers? And again, we see that root 8 come back. So even though I'm kind of going back to the same question I talked about, since somebody posed this specific one, let's just remind ourselves again, oh yeah, I can see root 8 is actually not simplified, and it's 2 root 2. So 2 comes out from the 4. That gets me an 8 in front, and there's a 2 left inside. So I can see that actually this answer is not horribly wrong, but is not entirely correct. And when fully simplified, will morph into this answer. So square root of 128. So, and just to kind of show us, so square root of 128 was 4 root 8. So assuming that you can get to there, then we're going to break this up. That is a 2. So I have a 4. Out comes a 2. So if you like to color code, that's that. And that is that. And this is stuck inside without any friends. And we get 8 root 2. And then back to the question that somebody posed, which was, um, can you check your answers? Well, now I can think back. If I were to change this back into the original one, this 8 actually probably came from a 64. And 64 times 2 is 128, which actually tells me that if I were to do this problem again, and I remembered this, I might use this factor tree so that I can go a bit quicker through this and not need to do, not maybe need to simplify 2 times, sort of like with fractions, right? Sometimes when you first learn how to simplify a fraction, I used this analogy before, that if you had an example like, um, you might start by dividing by 2. And then you would divide by 5. But in as you got better at this, you then maybe started to realize that 10 is better, or that you can just eliminate the zeros. And the same thing will happen with square roots and radicals. I hope you found this helpful. If you have a question that comes up, the next office hours will be on Thursday, and I'll post some info on that, as to whether I'm just going to make a video or if I'm going to host a Google Hangout. But keep posting questions either through Google Classroom private comments, um, or through just email, and I will get back to you. Hope everyone's doing good, and hopefully we can see one another on the internet and or face to face soon.